See, consider an op-amp circuit shown below. Find V0 when switch is closed. When switch is closed, that means there is no, here 4 ohms is short circuited with the switch. Here this point is V0, and from the virtual short circuit concept, this node is also having a potential V0. Because of the switch closeness, this V0 appears here, that is this one. Similarly this one, all these node potentials are V0. So there is no current towards this side, that is current is 0 into the op amp. This is V0, this is also V0. So V0 minus 6, if we apply the KCL at this node, V0 minus 6 2 by V0 minus V0 by 4 equals to 0. V0 is equals to 6 ohms. Okay, from this one option B is correct. Similarly, find V0 when switch open. Okay, when switch is open, options are A 12 volts, B 6 volts, C 3 volts, D 4 volts. Okay, switch is open, this node potential is V0, now also V0, but because of this resistor, this node potential is not equals to V0. But what happens is, this 4 ohm resistor, this 4 ohm resistor, means this node potential here V0 equals to, if I am indicating this one is V01, V0 is V01 by 8 into 4, that is V01 by 2. So V01 is nothing but 2V0. Okay, so now if we apply the, if this is V01, this is also V01. If this is V01, this is also V01. If this is V01, this is also V01. So if we apply the KCL at this node point, that is 2V0 minus 6 by 2 plus 2V0 minus 2V0 by 4 is 0. So V0 is nothing but 3 volts. Hence option C is correct. Here the network. Diode capacitance C0 equals to 100 under root VB picofarad. The circuit shown below is the frequency determining the circuit of the VCO. Unmodulated frequency of the VCO output is 10 power 6 Hz and is applied to a frequency multiplier to produce FM signal with FC 64 MHz and the modulation index is 5. Okay, so we know that the frequency determining network of VCO frequency is nothing but 1 by 2 pi under root L. Because of the diode, equivalent capacitance is C0 by 2, because those two are in series, means it is kind of a parallel multiplication. So here C0 is given as 100 by VB picofarad, C is 100 picofarad, F0 is 10 power 6 Hertz, L is 200 microhenries. If we substitute all these values, we will get VB as 2.51, we will get this as 3.49 volts, which is option B is correct. Here we have to find out frequency deviation. So we have to calculate the frequency deviation of the signal applied to the frequency multiplier. At the output of the multiplier, we are getting an FM signal whose carrier frequency is 64 MHz and the beta is, that is the modulation index is 5. Means before multiplier beta is nothing but 5 by 64. So we have to get frequency deviation before the multiplier, that is del f is beta into FM, that is 5 by 64 into 10 kHz, that is 50 by 64. that is 0.78 kHz, which is option D is correct.